Inflection points are where we change concavity. So inflection points are where we switch from being concave down to being concave up. Okay, concavity, it's about the second derivative. So we want to take a first derivative. Sorry about that. So we want the first derivative. And so these are two different functions of x that are multiplying to each other. That means we need to use the product rule. The derivative of the first function is a 1. The second function kept the same. Plus the first function kept the same times the derivative of the second function. Right? Remember, the derivative of e to the x is just e to the x. So there's our first derivative, but concavity is talking about second derivatives. Inflection points are about second derivatives. So the derivative of the first term is itself. The derivative of this term, it's x times e to the x. So it's the derivative of the first times the second kept the same, plus the first kept the same times the derivative of the second. And then you can combine e to the x plus e to the x. That makes 2e to the x. Okay, so there's our second derivative. We want to set the second derivative equal to 0 and find any place where the second derivative fails to exist or where the second derivative equals 0. And those are all the potential switching points for concavity. Okay. Let's see, though. You can factor out an e to the x, and so we should always factor if we can. That's what it looks like when you factor out an e to the x, and then we try to set each factor piece equal to 0, but you're never going to be able to make this term equal to 0 because x is in the exponent. You can't plug in a number in here to make this equal 0. In other words, this is an equation that does not have a solution, right? So that one's out. That factor piece doesn't help us. It doesn't give us a place where the second derivative fails to exist either, because there's no divide by 0 problems, no square roots of negatives. But if we set this factored piece equal to 0, we do get a potential, x plus 2 equals 0. You get x equals negative 2 if you set this factored piece equal to 0. Negative 2 is a potential inflection point, okay? So here's negative 2 on our number line. We want to check concavity to the left and to the right of negative 2. So let's just pick any old number. I'll pick negative 3. Try not to make it too big. And we don't even care about what this number is. We just care about the sign because we're wondering whether it's concave down or concave up to the left of this place. So if you plug negative 3 into the second derivative, because that's concavity, is talking about the second derivative, you get e to the negative third, which is going to be a positive number in your calculator, plus, this is going to make it complicated, negative 3e. Okay, actually, we can just plug it in. We don't need the calculator. So I'm plugging in negative third in here. Negative 3 goes in for this x as well. These are both e to the power of negative 3, so these are like terms that can add up, and we get negative 1 e to the negative 3. Remember, this part is positive. So if you multiply it by a negative, this is going to be negative over here. Okay? Plugging in negative 3 into the second derivative gives us a negative number. So we can rest assured that since negative 2 is the only place where we could potentially switch concavity, it's going to be negative all the way to the left on the number line. Now we need to test the value to the right. If we plug in 0 to the second derivative, if you plug in 0 in here, 0, 0, 0, the whole thing actually makes 0. I don't know why I pointed over here. Oh, no, shoot. Oh, man, I'm stupid. No, that's going to make e to the 0 power is 1. E to the 0 power is 1. And then 0 times e to the x, that part's 0. So I got 2, a positive number, right? So I test the number to the right of negative 2, and I got something positive. That means it's going to be, the second derivative is going to be positive all throughout here. So it's concave down over here. It's concave up over here. That means it's switched concavity at x equals negative 2. So negative 2 is the only inflection point.